Dear all, welcome to Civil Services with ZAKI. Today we are going to discuss about the one of the most significant topic in the climatology, and it is what is humidity. So in this topic we will discuss and address the following questions like what is humidity, what are humidity and vapor pressure, what is absolute humidity, what is water vapor capacity, what is relative humidity, and what is specific humidity. And we also see the global pattern of the specific humidity, whether it is equator or the pole, south pole or north pole. So for this, please stay with us and don't forget to subscribe my channel and tell your friends and colleagues about this video. And if you want to any topic regarding the geography, ecology, environment and science and technology, then you write in the our comment box. So we move forward and see what is humidity. So if we see the amount of water vapor in the air is referred as a humidity. So humidity is sometime we can sense or effect whether air it feel or humid dry. So it is humid or dry, we can feel it. We most are familiar with the one measure of the humidity is relative humidity. As we know, we see the various weather report and what is the relative humidity of New Delhi, what is the relative humidity of Patna and other some city. So we familiar with the relative humidity, but a term is basically commonly used in the daily weather report. But there are another measure of the humidity, and some of which are more useful in comparison to the amount of the moisture between different elevation, times and regions, etc. So understanding humidity leads to much better understanding the weather and climate. So if we understand the humidity, we can better understand the weather, climate and etc. So let's move forward and see what are humidity and water pressure. So what are these things? Water pressure and water vapor pressure and humidity. So the atmosphere nearly all nitrogen and oxygen. As we know, 78% of nitrogen, 21% approx oxygen and very less amount of the other gases. So if we consider the water vapor, it is a variable, but it is 1 to 4%, as we earlier discussed about our previous video, how many water vapor present in the atmosphere. So amount of water vapor, so the term humidity conveys the amount of water vapor in the atmosphere, and the amount of humidity can be represented several ways. So we can represent it several ways, like specific humidity, absolute humidity, relative humidity and so on. So let's move forward and see humidity and vapor pressure. So assume these two cubes and see these. So imagine two cubes, both are the same size and particularly filled with the water, but mostly filled with the air. So particularly, it means here we fill it with the water, and most of the part of this cube filled with the air. So if you see here, these blue dot are the water vapor. So see here, water molecules have evaporated from the liquid water. So they evaporate from these liquid water and becoming a water vapor in the air. So here the amount of water vapor in the air is humidity of the air. So it is this humidity. So this is called humidity. So it is less humidity, it is more here more humidity. So in this figure, as you saw in this figure, a small blue dots is in the air is the humidity. So these molecules are the water molecules, and it is considered as the humidity. So let's move forward and see in these topics. So what is absolute humidity? So if we capture all the weights, all the water vapor in either cube, whether this cube or this cube, we can assume capture all these molecules or all these molecules and weight it. So water vapor in cube, and we could determine how much water vapor is the volume of the air. So either we could determine how much. So how much in these all water vapor volume, and such measure are called absolute humidity. So basically it is weights all the capture and weight all the molecules in the water. So it expresses as the mass per volume. So mass per volume air is called absolute humidity, and it is expressed as per gram per cubic meter. So it is gram per cubic meter. Gram per cubic meter is absolute humidity. So in this we saw it is 10 gram, and here absolute 10 gram per meter square, per meter cube, and here is 20 gram. It means doubles. So the specific humidity, absolute humidity, here is 10 or here is 20. So the absolute humidity, it means total count of the water vapor by weight in the volume of the total air. So it is called absolute humidity. Now we move forward and see what is vapor pressure. So vapor pressure, so the amount of vapor pressure, as you see here is less water vapor molecules and here is more water vapor molecules. So it means here is more weight, here is less weight. As it's 10 gram or 10 kilogram, or it is 20 kilogram. So 20 is more, it means it create more pressure by the weight. So by the water vapor is called vapor. So the amount of pressure contributed by the water vapor. So these water molecule exerted some type of the pressure. So these pressure, water vapor pressure, are called vapor pressure. So this is called vapor pressure, and vapor pressure is expressed using the same unit as the millibar. As we know, we use the air pressure as the millibar, as you know our previous video on the air pressure. So it is also expressed is the millibar as a unit millibar, but it indicated vapor pressure indicated by a small e. So indicated by a small e, and the unit is millibar. So we move forward and see the water vapor capacity. It is one of the most important things. So air can include only limited amount of water vapor, and the maximum amount it can include is called water vapor capacity. So see here, if this contain that amount of water and we can include this, so the all, if we say assume all these area are called water vapor capacity. It means if we include more than that, then it is overflow. It means they cannot hold that amount of the water. So it is called the water vapor capacity. So maximum amount, so it is maximum amount can include is called water vapor capacity, commonly depicted as ES. E vapor pressure, S is saturation point. So here S stands for the saturation. saturation point. So the water vapor capacity of the air varies by the temperature of that air as shown in here. So it varies by the temperature. So here water vapor capacity, see here water hold only 10 degree, they only hold 10 millibars, but and got the saturation point here. But if we assume 30 degree, then the saturation point is on the 40 millibar air pressure. So if temperature increases, it means the water vapor capacity also increases. That's why if you see the humid area and warm area capture more water molecule than the colder area. So that is called water vapor capacity, as cleared by these graphs. If you want more about, then you can join our foundation batch in sub IAS study, and you can ask me directly by these type of the question: what is absolute humidity, what is water vapor pressure, what is the relative humidity, what is the specific humidity, and so on. So we move forward and see another thing is relative humidity, the most common thing about the relative humidity. So a common way to convey the humidity is expressed as the ratio of how much water vapor in the air relative to the maximum amount of the water vapor is possible. It means the water vapor capacity. So water vapor capacity relative to the water vapor capacity, what amount of the water presented at the time. So it is called relative humidity. So in this graph we show the green dot represent the vapor pressure at 20 millibar at 29 degree C. So if you see here 20 millibar vapor pressure means capacity and 20 degrees Celsius. It means here it is the same temperature 29 degrees C, but pressure is here less. It means 20 millibar. So here this is unsaturated. It is unsaturated and it is saturation point. So saturation point. So if we increase the pressure and go to the 40 millibar and the same temperature 29 degree, it can be saturated. So here relative humidity is 50% and here relative humidity is 100%. So that's it is relative humidity. This comparison with the how much amount water can hold at the given temperature and the pressure. So it is called relative humidity. So we next go, it is so, and it is the saturation line. So it is saturation point, dew point. So we move forward and see another thing is what is a specific humidity. A specific humidity is one of the most important thing after the relative humidity. As you know, relative humidity is also very significant for the predicting the monsoons, weather report at various places. So relative humidity help describe how humid air feel to and indicate how close to the air is to be saturation. But the relative humidity varies with temperature. As we know, temperature increases, relative humidity decreases. So pressure increases, relative humidity increases. Even if the amount of water vapor in the air has not changed, but due to the temperature increase, relative humidity can increase. So therefore due to temperature, the relative humidity can increase or decrease, whether it is depend on the temperature. So therefore we also use another measurement of the humidity is called a specific humidity. So see, which compare, so a specific humidity compare mass of the water in a body of air to the total mass of the air. So here total mass of the air and the total body of the total air. So an advantage of this approach is a specific humidity measurement is not affected by the, so if we see the specific humidity, it is not affected by the change in the temperature, pressure, volume, etc., because it is the comparison between the mass and the air, total mass of the air and total water vapor, total water vapor percent, total water vapor percent, mass of the water vapor and total mass. So it is not it is not including like the absolute humidity is the volume. So it is not volume, it is mass. As you know, mass not decrease or increase, so it is independent from the temperature, pressure and volume, and that occur when because this type of the present in the air masses. So air masses move up and down and various topographic feature due to. So what is air mass? If you want to know more about what is air mass and all that, then you must subscribe our channel, because we will provide you the new video on this, what is air mass. So for this and all other concept regarding the geography, ecology, environment, you can subscribe our channel and tell your friends and colleagues, because the subscription speed is very less till yet. So now we move forward and see the specific humidity. So see, if assume the total mass of this cube and the total mass of these water molecules. So this cube contains molecules of the water vapor shown in blue dot and dispersed through the mass of the atmosphere. So if we assume this cube is the atmosphere filling the rest of the cube, in this example the mass of the all water vapor is 12 gram. So if we assume all the water vapor is 12 gram and the total mass of the air including the water vapor include the water vapor is 1 kilogram. So if we can formulate is that type of, so mass of the total water vapor by mass of the air equal to a specific humidity, and it is depicted as a small q. So here if if we put the 12 gram by 1 kg equal to 12 by 1 kg is the specific humidity of this certain places. So this specific humidity can vary from place to place, whether it is depend on the topographic features, whether it is humid place, where is the dry place, and all that. So we also can compare a specific humidity and capacity. So if you see here in this graph, basically in this graph you see here this graph for a specific humidity and the temperature. So temperature don't not affect the specific humidity. So the temperature which the blue line is the saturation point, blue line showing the condition where air is saturated and water vapor. So the green dot represent that the specific humidity at 10 gram per kg at the temperature of 30 degrees. So here if you see here green dot here 30 degrees C and 10 gram is it is a specific humidity. So specific humidity 10 gram per kg and here is 30 degree. So if we decrease the temperature and goes to the 10 degree, then the specific humidity is the same, but the air molecules are saturated. So if we cool the air moving left on the graph and the air can reach the saturation point, red dot, here red dot is saturation point, but note the specific humidity, so here note and recognize that the specific humidity does not change because of the temperature. So that's why specific humidity are very significant for the climatology. So we move forward and see comparison between the water vapor capacity, specific humidity, relative humidity. So assume the temperature. So temperature increase, water vapor capacity increase, specific humidity don't affect, and relative humidity decreases. So if we see temperature 40 degree, water vapor capacity 50 gram per cubic meter, specific humidity 10, and relative humidity 20%. So we further move and go to the 10 degrees Celsius. So 10 degrees Celsius, water vapor capacity 10 gram per meter cube, and specific humidity 10. So specific humidity here 10, 10, 10. So specific humidity don't change in any given conditions. Basically the temperature, increasing the temperature. So temperature not affect the specific humidity. Remember, that is very significant for your competitive point of the view. Competitive point of view. So here relative humidity 20% and here 100%. Here 60. So relative humidity increases when temperature decreases. It is also notable that if temperature increases, relative humidity decreases. Temperature increases, here increases, relative humidity decreases. Temperature decreases, relative humidity increases. Specific humidity don't affect it. But water vapor capacity, if temperature increases, water vapor capacity also increases. Remember, these are the very significant point for the competitive exam view. So let's see the global specific humidity. So if we see, it is global specific humidity, and see here equatorial region has more humid places. So if you see the southern hemisphere, these area are not much very complex and it is so simple. But if you go to the northern hemisphere, here due to the land you see very contrast and very complex of the humidity, specific humidity across the globe. So if you go to the mid latitude, here less humidity. If you go to the higher places, such type of area, this is more humidity, and if you go to the desert, less humidity. So it is the global pattern of the specific humidity. So that's all about the humidity. So what is humidity? So now we move forward, and we also provide you a new video series about the current affairs after the last of this month, and basically, or maybe in the first week of the October, for a specific basically a specific week for the current affairs, basically current affairs related to the geography, ecology, environment, and science and tech, because these sections are very significant. So thanks for watching this video. Before we going before we leaving this session, we once again request you, please share this video and don't forget to subscribe my channel, and tell your friend. If you are subscribed, then you share this video. If you are still not subscribed, then please subscribe this channel. Thanks for watching this video. Thanks a lot.